And so at this point, I think what I want to do is turn to our last session for this sort of quick fire presentation area. And we're going to be hearing from Core Power from Tony Huston and Giulio Gennaro. And they're going to be speaking about the new nuclear at sea $1 trillion economic disruption opportunity in the marine sector. You'll see tomorrow that the marine sector will be part of the discussion of the industrial sector in the workshops. And so we're very excited to have this little bit of an intro. And then again, I'm probably going to ask to defer questions and ask people to join in at the Zoom session, which we will be starting at 2. Although if we run over here, people can still pick where you want to be, and we'll catch up. Thank you. Tony and Giulio, let me turn it over to you.
So quick word of thanks to Don and the team at GW Law. Thank you very much for inviting us to participate here. This is a great event and great exposure for us at Core Power. We're really kind of honored to be in company with all the luminaries of nuclear today and this week. I'm really excited about this program because it's, as an investor, this is really what we're focusing on, right? So your entire structure of investable nuclear is really right up our alley. So our presentation will be about 10 to 15 minutes. It'll be in 2 parts. I'll quickly give an overview of the broader marine and maritime industry so you have a sense of what the magnitude is of this and what is our approachable market. And then Giulio will take it from there and get a bit more technical and you understand the products we're going into, right? Can we get the next slide, Giulio? Okay, great. So at Core Power, we are a marine innovation company, right? We are the ones who are trying to innovate in this industry and make sure that this technology is applied to a real, very large and deep market. We were originally founded in Singapore, which is what you're seeing behind me, the harbor full of all these ships, by Mikal Bo. Mikal couldn't be with us today. He's actually in Singapore this week, and sort of a visionary CEO who was a risk manager in shipping and saw this looming issue with decarbonization and with fuel supply and with fuel price volatility, and realized that after all the thinking and all the research on synthetic fuels and different propulsion systems, that he kept coming back to nuclear. And advanced nuclear is where we have landed in terms of our first foray and our first participation and investments. So our mandate is to source, fund, and apply new technologies into the maritime industry, the marine industry, and really to create the products that solve these large problems of, we're trying to make better, faster, more efficient ships over time. I really like Dr. Cross's presentation where he speaks about the iteration of integration and innovation. And that's really what we're doing. We're not reinventing a wheel. We're really taking 2 wheels and making a bicycle or making a more functional industry. Next slide, please. Thanks. So global trade and the marine industry are really, they work hand in glove. Without the marine industry, there would be no global trade. They're currently what you're looking at here is a heat map of the global trade path, the highways of our industry, right? So there are now currently about 98,000 ships crawling around the planet, distributing 80% of global goods, whether that's energy or container ships. The value of that industry is about 19 trillion a year. As a standalone industry or country, it is about the size of the United States as an economic powerhouse. That 98,000 ships consumes about 380 million metric tons of high carbon fuel per year. Bunker fuel is toxic. It's, I think, 75 or 85% carbon. It's just terrible stuff. So under that reality, with the IMO, the International Maritime Organization, mandating a 50% cut in CO2 levels, we had to find real solutions that made sense for an industry that needs reliable, available, affordable power on a 24-hour-a-day basis. Thanks, Giulio. The fleet dynamics, this is what you're looking at, the gray area. The gray bars are ships, all those ships are aging out, right? This fleet is like any other fleet. The postal fleet, McDonald's fleet, whomever, that they run a fleet of ships and entities that ultimately run to their life cycle. So the bulk carriers, the container ships, the oil tankers, all have a lifespan. And as you can see from the gray bar areas, this is getting to be a fairly old fleet in entirety. So our economic opportunity is to replace those ships with new constructed ships with advanced atomic and also with fuels, the fuels that we will supply via synthetic production. Thanks, Giulio. And I'll just close up with monetizing this transformation. This has happened before. What you're looking at here is 1870s Melbourne with a dock of tall ships that are being serviced by a steam engine. And this is where we see the parallel, the analogy to advanced atomic with the current fleet of vessels, where this emerging technology is being prepared and tested for the application into a greater industry. This is one of the greatest industrial disruptions we've ever seen. And to many people who are not in the maritime industry, they don't really see the vessels. They don't see the breadth and the depth of the industry. So our role really here is to work to bring all of this technology into the shipping industry and to bring it to fruition. And it's perfectly suited for us. We're an industry that has a demand on a mass basis for a standardized power unit, and the nuclear industry is looking for a mass market for just that, mass manufacture and standardization of product. So with that, I will hand it over to my colleague, Giulio. Giulio is our Chief Technical Officer. He's a chartered mechanical engineer with over 20 years of experience in the maritime industry, with particular expertise in the fields of ship propulsion, energy efficiency, emissions, and externalities. He's a very modest man, so he wouldn't do his own intro, but I'll make sure that you know he's the brains behind a lot of this. So with that, Giulio, please.
Thanks, Tony. So as Tony was saying, we believe that nuclear is needed to move forward and to provide sustainable decarbonization for shipping, but not just for shipping, for the entire marine, let's say, ecosystem. Now, why not conventional nuclear? Now, you will never hear us say that conventional nuclear PWRs are not safe. They are extremely safe, and also the US Navy records just show it. The problem is that current state-of-the-art pressurized naval reactor, the pressurized water naval reactor, run on highly enriched fuel, which is not allowed for civilian application. If we were to run them on low enriched fuel, they would need relatively frequent refueling and long outages, which is, let's say, conflicting with commercial requirements. But more important, being those reactors pressurized, they have a quite large emergency planning zone. So now consider a ship with a 10-kilometer, or let's say 5-mile radius emergency planning zone moving around harbors, berths, canals, and this is just conflicting with commercial requirements. So this is not a way that can be used to move forward. We need advanced reactors. So we have identified 3 criteria that we believe are the key for advanced reactor at sea. So the first criteria is that we need a very long fuel efficiency, very high fuel efficiency, and very long fuel cycle. Possibly, we need a fuel cycle that is as long as the life of the asset. So let's say 30 years. By being able to fuel the reactor at commissioning and let's say drain the reactor, remove the fuel at the commissioning, we can mitigate greatly the proliferation risk. Another key aspect is that we need reactor that can be, let's say, built, assembled in a modular way, and then it can be mass produced in order to reduce the cost. And you have seen the numbers. So we need a very large quantity of reactors in principle. Even if we consider only 10% of the fleet, that would be 10,000 reactors. These are numbers that, I mean, I would say that the nuclear industry has never even dared to dream about. But the most important characteristics is that we need ambient pressure or low pressure core to have a minimal extent of the emergency planning zone. In principle, we would like the emergency planning zone to be confined to the reactor compartment or to the hull of the vessel, so as not to create any conflict with the commercial operation of the ship or of the asset itself. Now, what can we do? Let's take a very large container ship that is designed for a maximum speed of about 22 knots, down from the 26 knots that was the say design speed before the 2008 crisis. And these ships are currently being operated between 15 and 18 knots. Well, if we put nuclear power, we could operate these ships with a single fuel load at 30 knots for 30 years. We would go from single screw to multi-screw. They would be atomic electric ships. So you might know that nowadays cruise ships are diesel electric, and this would be, let's say, atomic electric. They would be, let's say, as zero emission as possible. Of course, we know that there is no really zero emission, but that's how we all say it. They will not be subject to carbon taxation. They would have no fuel tanks. They would have no funnels. They would have a small engine room, which translates into more cargo at higher speed and therefore higher profit. But it's not just container ship. Actually, the workhorses of the global economy are relatively large, but not as fast and not as flashy cargo ships like bulkers and tankers. So we can consider a very large ore carrier moving iron ore on a 60-day round trip. If running on low sulfur fuel oil, the consumption for each trip would be shy of 4,000 tons of fuel. And this fuel cost between $600 and $700 US per ton, plus carbon taxation when it will be introduced. And the emissions, just as far as CO2 is concerned, is slightly above 1,000 tons per round trip. Now, if we move to green electrofuel, which are now being considered, especially for shipping, let's say green ammonia, the fuel consumption now more than doubles. We would need shy of 9,000 tons of ammonia, and the cost would be 3 to 6 times higher. Now, if we move to high assay low enriched uranium, the fuel consumption per round trip is 1.1 kilogram, and the cost that we model is equivalent to operating the vessel on, let's say, carbon fossil fuel with a $450 US per ton cost. Now, considering a 30-year life for the ship, a nuclear ship like this would create additional profit for about $500 million US, which is a lot. So this is why we talk about sustainable decarbonization, because it's not just about reducing the carbon footprint, it's also about creating a new competitive advantage in the market. And this is not just for shipping, this is for the whole marine industry, and also to create energy to generate energy from the sea to the shore. I always like to say that it's not the sky, it's the sea is the limit. The sea is, I mean, the outer space closest to planet Earth in a way, and it's basically untapped. We can use it to improve the economy from the sea to the shore, and also to develop it sustainably. We can have floating power plant, we can have water desalination plant. Water scarcity is becoming more and more of an issue. We can use these, we can put at sea green fuel refineries, floating data center. We can start moving processing of materials from the land base to the sea. And we can do this doing proven offshore design. I would say, I would like to stress the point that offshore industry has proven that there are massive gains in moving processes from land to the sea. both in safety and in productivity. This asset would be constructed in shipyard, towed to site, and then towed back to the commissioning, thereby limiting very much, let's say, the site preparation, and also the return to greenfield would be much easier. Tony, back to you.
Thanks, Giulio. So look, we'll try to conclude quickly here. We're a company that's based in the UK, headquartered in the UK. I'm here in Washington, DC, a recent transplant to help us navigate the regulatory, industrial, and financial jungle or reality that we have here. And it's great to be here, but we're a part of a broader team on two sides of the Atlantic, working with the UK government, with people like Lloyd's Registry. For us, there are, of course, two sides to the regulatory world. We have of course, the atomic side. There's also the marine side. So that means all boats, all big ships have to be classified by the big groups like the American Bureau of Shipping in the United States. In the UK, we have Lloyd's Registry for a class society. So we're quite well advanced regarding working with these entities, particularly in the UK, who have embraced this as a national priority. And I'm optimistic that we will begin to embrace it more as a national priority now that we are here, our flag is firmly planted here, and the economic values involved, right? So we have common interests between us and the UK. And for me as an American particularly, it's good to be back home. I've been in Singapore for 11 years, and I came back to help establish this firm here and work with the great and good in the nuclear industry and the maritime industry to assure that this project moves forward. We all talk about the benefits of nuclear, and we're very fortunate to be in a position to be hopefully that Archimedes moment where we're the lever that really advances nuclear farther because of to be blunt about it, just the money. This is a huge economic positive disruption for our industry and our shipyards, our shore-based power, our marine industry, and the time has come. So with that, I will leave it up to any questions. If anyone has any questions for Giulio, we're happy to talk to anyone. We'll be around. Thank you again, Donna.
You're very welcome, and that was fantastic. It's a really important sector and one that's been very hard to decarbonize. So I'm delighted that you're working on this. Rather than taking questions now, I'm going to suggest that folks move into the networking session. If we have a lot of different conversations, we can do workrooms. Otherwise, everyone gets to benefit from the conversation all at once, and it lets people talk actually directly to one another rather than through questions. So with that, I'm going to terminate this session, invite you all to sign on to the next link. Hopefully you have it. If you don't, it's online on the agenda. And with that, I thank all of you for your wonderful presentations. Thank you.
Thanks, everybody. Thank you.